Hello, everyone, and thank you for being here today. I'd like to start our session with something very familiar to all of us. Think for a moment about the roads in a city, the roads where cars move back and forth all day. These roads are essential because they let vehicles travel smoothly, and they help the entire city function as one connected system. But imagine what happens when a road cracks or gets damaged. Traffic slows down, accidents occur, and in some cases, everything can come to a standstill. So whenever there's a problem on the road, construction workers or repair crews rush to the scene to fix it as quickly as possible. Now, why am I talking about city roads? Because something very similar happens inside our own bodies, specifically in our blood vessels, and with the help of something called platelets. You can think of your blood vessels as roads as well, roads that your blood travels through every moment of your life. And just like real roads, these vessels can get damaged. When they do, blood can leak out, and even a tiny injury can become dangerous if it isn't addressed quickly. That's where platelets come in. They're like the emergency construction crew of your body. They rush to the damaged site, stop the bleeding, start the repair, and prevent things from getting worse. So in a sense, platelets are our body's fast-acting repair team. And with that idea in mind, let's take a closer look at what platelets actually are. First, where platelets come from. Platelets are made in the bone marrow, and they come from very large cells called megakaryocytes. These megakaryocytes grow big and mature, and when they're ready, small pieces of them break off and enter the bloodstream. Those small pieces are the platelets we're talking about. They don't have a nucleus. They live for about a week or so, usually 7 to 10 days, and when they get old, they're removed mostly by the spleen. You can imagine them as small workers constantly traveling through your bloodstream, always on standby, always watching for any sign of damage. Next, what platelets look like. Platelets are tiny, just a few micrometers wide, and shaped a bit like small discs. Even though they don't have a nucleus, they contain little packets called granules, and these granules store important chemicals that help platelets do their job. Some granules carry growth factors and clotting proteins. Others carry things like ADP, calcium, and serotonin, signals that call in more platelets. And some granules carry enzymes to help break down clots later on. When a platelet becomes active, it releases these substances like tools from a toolbox, helping the repair process move forward. So how do platelets actually stop bleeding? Let's walk through the steps like a story. First, a blood vessel is damaged. This exposes collagen inside the vessel wall, like the foundation under a broken road. Immediately, platelets rush to the spot and stick to the exposed area. A special protein called von Willebrand factor helps them attach firmly. This is the moment when the construction crew arrives and secures the scene. Next, the platelets change shape and start releasing chemicals from their granules. These chemicals call in more platelets and prepare them for action. It's like workers setting up equipment and signaling more crew members to come help. Then, the platelets start sticking together. They form what's known as a platelet plug, a temporary barrier that quickly stops the bleeding. Think of it as putting up a temporary structure to stop cars from falling into a hole in the road. And finally, clotting factors in the blood create strands of fibrin that wrap around the platelet plug, making it firm and stable. This is like laying down concrete and reinforcing the repair so the road stays strong. Why platelet counts matter. Most healthy adults have about 150,000 to 450,000 platelets per microliter of blood. If you have too few, you bleed easily. If you have too many, your blood may clot when it shouldn't. Just like a city needs the right number of workers, not too few, not too many, we also need the right balance of platelets. Common problems related to platelets. Some conditions occur when platelets don't work properly. ITP, where the immune system destroys platelets. TTP, where small clots form throughout tiny vessels. Von Willebrand disease, which affects platelet adhesion. And bone marrow disorders, which affect platelet production entirely. To wrap up. So today we learned that platelets are far more than tiny fragments floating around in your blood. They are your body's first responders, your construction workers, and essential protectors of your circulatory system. They arrive first at any injury. Build a temporary plug. Support the formation of a stable clot. And make sure you don't lose blood from even the smallest wounds. Understanding how platelets work gives us important insight not only into basic physiology, but also into many medical conditions involving bleeding and clotting.